to your last lesson of this week. We are still going to continue with with transformations, but we're only going to focus on the transformations that have rigid transformations, if that makes sense. So, what you're looking at today is just rotations, okay? So, before we start, I am going to go over vocabulary with you. You are going to hear me use the word corresponding a lot, okay? You'll hear it in the lesson activity. You'll hear it, with our meetings and stuff. But corresponding, so your shapes are going to have corresponding sides and corresponding angles, okay? So what they are they're a pair of matching angles or sides that are in the same spot in two different shapes, okay? Sounds confusing? Now I want you to think of like a classroom, okay? If you think of a classroom, and think of the classroom right next to that classroom that you're thinking of, okay? And if we were in the same schools right now, I would refer to a teacher, but we're not, okay? So let's say I have a classroom. This is my classroom, and the classroom next door to me has the same classroom as well, right? And here in my classroom, let's say that on my classroom, my chalkboard is right here, okay? So that means on the other classroom, the chalkboard may be in the same spot as well, okay? Another example, the way you enter a classroom, okay? So again, just think of like your standard math classroom. Let's say the way you enter my classroom is through this door that's on the bottom right side of the classroom. Well, in this case, the classroom next to me, you enter the same door in the same location. Okay. Now look at what I just highlighted. The chalkboards represent corresponding sides because again they're in the same spot in two different shapes, just like the location of the door. Okay. Again, think of your standard math classroom, and then think of the classroom right next to that math classroom. I'm pretty sure the doors and how you enter are on the same exact location. Meaning, if in this drawing, my door is on the bottom right, so that means in another drawing, in another classroom, that door is also on the bottom right of like that drawing. So that's an example of corresponding sides, and then corresponding angles are the same thing. Okay, here's some examples of corresponding sides, corresponding angles. Notice for my triangles right here, on the left side of this, I have corresponding sides and corresponding angles, okay? Now, if you look at angle A and angle X, they are corresponding angles because they're in the same location of that exact shape. Just like angle B and angle Y would be corresponding angles, and then angle C and this would be angle Z are also corresponding angles. Okay, your side or your line segments can also be corresponding. So if you look at the length of JK, the corresponding side to JK is RS. Okay, if you look at the corresponding side JM, or if you look at JM, the line that's corresponding to JM would be RU. Okay, and then last but not least, or not last but not least, but just another example, the line KL. Corresponding side to KL would be ST. Okay, so you're going to hear me say those vocabularies a lot, especially in the lesson activity. Okay, and again, here are some other examples of corresponding sides and corresponding angles. I'll have you look at that. You can pause it and kind of see what I mean by corresponding angles and corresponding sides, okay? So just to review what rigid transformations are with you, they are basically transformations where the shape and the size of that figure do not change after that transformation, okay? Now, if you remember from our last section, there's a total of 4 transformations. Only 3 of those transformations are rigid. And again, when I talk about rigid, I'm saying if I tell you to translate or transform an image and the size and the shape does not change, they are rigid transformations. So what you're going to do is You're going to look at rotations today, and then you're going to look at reflections and translations next week. Okay? Now, a rotation, you're going to learn today with your lesson activity that when you rotate a figure, the measures of those interior angles and the length of their line segments do not change at all. Okay, that's basically what a rigid transformation is. The measures of those angles, the length of the size, or the length of the line segments, the length of the size, they do not change at all. Okay, so what we're going to do now is I'm going to go ahead and go into our lesson activity where you're going to learn a key characteristic of rotations and why they are rigid transformations. Here is your rotations activity. Again, you're going to learn some key characteristics of rotations and again why they are rigid transformations. So again, you're going to use the GeoGebra activity, so just click on that. And what you're going to do is there's like a total of 5 problems and we're just going to go ahead and answer it. Okay, so looking at question 1, it says move the slider to rotate your triangle ABC, and what you want to do is you want to identify when the triangles or the final image coincides with these following triangles. Okay, so again, I'm going to start off with triangle ABC, and I'm going to rotate it to identify when it, overlaps on this triangle, which is DEF. So if you look at DEF, or just to take a step back, remember rotations are basically the process where we turn our figures counterclockwise. Okay, so again, what they want us to do is I'm going to look at triangle ABC and I'm going to rotate it to where it's going to sit on top of triangle DEF. And if you do that, what you want to do is you just want to record the measure of that angle. So at 45 degrees, triangle ABC sits on top of triangle DEF. Okay, so that's what I'm going to put. Next, I have, so at angle ABC, we're just going to put 0 degrees. Okay, and then I'm going to identify when it hangs or when it sits on top of triangle GHI. So here's GHI. And at 115 degrees, that's where it sits on top of it. So you should be able to do, triangle JKL on your own, hit submit, and then scroll down to question number 2. Okay, looking at question number 2, it says create a circle with the center P that passes through A. You're going to create 2 more circles, one passing through B and another passing through C. Use the slider again to rotate the triangle. As the triangle rotates, what do you observe about the respect to the circles that you made? Okay, so you want to create a circle where P is the center. So here's, again, I'm going to click on the circle tab and it says circle with center through point. That's what I'm going to do. Okay, so I'm going to select the point where P is the center. So if they want P to be the center, this is the point that I'm going to click on. And I'm just going to drag my cursor until A is a point on the circle. Now notice that A is now a point on the circle. Okay. Create 2 more circles, one passing through B and another passing through C. Use that slider again to rotate that triangle. As the triangle rotates, what do you observe about the respect to the circles that you made? So what I'm going to do now is I'm going to create another circle where it passes through the point B. So again, C is going to be my center. And I'm just going to go ahead and, again, the goal is to make B my point. So here, B is a point that passes through that circle. And again, you want to do another one to where C, or you want to create another circle where C is going to be a point that passes through that circle. So I'm going to click on the circle tab. Again, my center is P, so I'm going to click on P. And I'm just going to go ahead and drag this cursor until the circle passes through the point C. Okay? Now, what they want us to do is they want us to rotate it. So notice as we rotate our figure, how all the vertices, okay, the corresponding vertices, they all rotate against that circular arc, okay? So let's say I took off, I'm just gonna go back, okay? So notice how the first circle that we created, point A, point D, point G, and point J, those are the corresponding angles that I talked about earlier, right? They're all angles that are at the same location within a different shape, okay? So they're all like this. Like if I just look at and I clicked on, I'm going to zoom in. This is triangle ABC. Notice how triangle or point A is like on the bottom left of this triangle. Well, that means that point D would also be that corresponding angle with angle A, as well as, angle G, as well as angle J. Notice how when you rotate it, they all rotate around that circular path, okay? Now, again, when you create another circle and we focus on angle B, notice how, again, the corresponding angles to angle B all rotate around this circular path as well, okay? And then again, creating another circle with our third point, which is at C. Notice how all the corresponding angles, again, circulate around this circular path as well. So that is the observation that we're going to make. As triangle ABC rotates around the circular path, each of the points also move along the circular path, okay? And that's what you would put. And then make sure you hit submit to get for it to save your work. Now what we're going to do is we're going to look at question 3. So it says measure the angles of your triangle, and then you're going to measure basically all the corresponding angles with the other 3 triangles, okay? So I'm just going to do, the first 2 with you, and you can do the remaining 2. So again, we're talking about corresponding angles, so I'm going to just like delete everything. So to delete, the circles that you just created, you're just going to press this back button, okay? So I'm going to measure angle A, angle B, and angle C, okay? So if I do that again, you're going to click on this measuring angle, you're going to click on angle, and I'm just going to click what I've been doing, and because I've been practicing with this, is that I'm just going to go ahead and keep clicking on, the sides and stuff, okay? Because your goal is to try to get the measure of your interior angles. It's going to take a while. Okay, so I was able to get the measure of that. And notice what I'm doing is I'm clicking on, at least 2 sides to measure the angle. And I can't, for some reason, I just cannot do the interior. Oh, I was able to do that. So I don't know how I did that. Okay, so let's see. I think if you just drag it, click on it, and drag it, that's what I'm doing. Yeah. Okay. So what I'm doing is I would click on this link or the side link, and I would, oh wait, I can't drag it. Okay. Measure angle. There you go. Okay. So this is basically, I want to make sure, oh yeah. So this is the measure of the angles, okay? So angle B is, or I'll say angle A, let's just round it to 53 degrees. Or I'm sorry, looking back at this, this is saying angle ABC. So notice how B is my vertex of this, for this line. I'm going to look at what the measure of angle B is, and I'm going to say that's 97 degrees. Okay. If you look at angle ACB, C is my vertex, okay, because C is, and I deleted that, C is the middle letter, so that's how I know. So if you look at C, I'm going to round that to 30 degrees. And then angle BAC, again, A is my vertex, so I'm going to look at A, and I'm just going to say A is 53 degrees, okay. Now you're going to repeat the same for angle DEF, angle DFE, and angle EDF, okay? So click on the angle measurement, and I'm just going to click on, like I said, I would click on a side and I would drag it, and that's a little different. But again, click on the side and drag it. That's what I did. Click on this side and drag it to the opposite side. Oh wait, I'm sorry. You have to continue to click on this. I don't know what's... Okay, so just know you're going to have to really play along with this. But you'll see a pattern going on in a bit, so that's why I'm not really stressed about you guys. Okay, so click on this angle. Okay, I guess you have to wait until you see how the side is, like the length is highlighted. So click on that. Notice how it kind of gets highlighted. Okay, maybe I should try this side. Okay, so what I'm doing is I'm just dragging it. So you'll see, and I think this is all that you would have to do, but look at our corresponding angles. Angle A's corresponding angle is angle D. Angle B's corresponding angle is angle E. Angle C's corresponding angle is angle F. Okay, notice how they're all equal. So there's like a pattern that you'll see with the measure of these angles. Okay, so you know what? I can just go ahead and write these down for you, or record these down for you so you can see. And I'm just going to go ahead and hit submit. That's all you would have to do. Okay, looking at question 4, it's going to say, how do the measures of these triangles compare to the rotating triangles? What can you say about the preservation of the angle measurements of a shape during a rotation? So I basically, restated this at the beginning of the lesson. The measure of the angles do not change. They stay the same after the rotation. Okay? And that's basically what a rigid transformation is. Okay? Let's go ahead and look at this. What you're going to do now is we're going to repeat the same process, but we're measuring the length of our sides. Okay? So it tells me to measure the length of AB, measure the length of BC, measure the length of AC. So again, to measure the length, I'm going to click on this. Distance or length, that's what I'm going to do. I'm going to measure what the length of AB is. That's 1.37. So I'm going to write that down, 1.37. Next, I'm going to measure the length of BC. So from B to C, I'm just going to click on BC, and they tell us it's 2.24. And I'm going to find the length of AC, which is going to, if I just click on it, I believe it's 2.76. Okay, and you're going to measure the length of the other 3 triangles. So again, measure the length of DE, 1.37. Okay, measure the length of EF. Okay, so from E to F, if I click on the line segment, it's 2.24. And again, the length of DF, if I click on that, it's 2.76. So you'll see a pattern going on, okay? Because again, they're corresponding sides and corresponding angles, okay? So how do the measures of the side length compare with the 3 triangles or the 2 triangles that we rotated it to? What can you say about the preservation of the side lengths of a shape during rotation? The side lengths remain the same and do not change after a rotation. That's basically what, in simplest words, of what's going on. Okay, hit submit, and then guess what? You are basically done with this lesson and this activity, because you just have to do your self-evaluation. All you would have to do is hit print. Make sure that you turn this in. It is Friday. Make sure you submit this in so you can get full credit for it. I hope this was an easy lesson for you to understand, okay?